A pleasant day to everyone. We're here to discuss the four pillars of object-oriented programming. The presenters are me, John Lloyd Andres, Princess Jade Domingo, Clarice May Elia, Maria Angela May Perez, and Francesca Tagonon. This presentation includes first, the four pillars of object-oriented programming, second, data abstraction and its examples, third, encapsulation and its examples, fourth, inheritance, its types and examples, lastly, polymorphism, types and its examples. So basically, OOP or Object-Oriented Programming is a programming paradigm that uses objects and classes to create structured and reusable code. OOP is based on four core principles, often referred to as pillars. They are encapsulation, abstraction, inheritance, and polymorphism.
Good day, everyone. My name is Francesca Pitagonan, and I will be the one explaining the first pillar of OOP, which is data abstraction. So, what is data abstraction? Data abstraction, it is an OOP technique that hides implementation details and only shows the essential information. Abstraction is showing users only what they need to know and hides the implementation details to not make it more complicated to the user. Secondly, user focus on what it does without worrying about how it works. It simplifies things by letting user focus more on what the thing does rather than how it works. This way, the user can interact with the system or without worrying about the details of its operation. This is the first example of the implementation of the data abstraction. So we are here on the main class and let's create a new class. Let's name it person. So here in class person, we want them to have the ability to talk. So let's create a method called talk and have it print I am a person. And let's go back to main and create an object and call the talk method and run this. So this is an example of a data abstraction. You do not care about how the talk method works or what it prints and how it prints. You just care about using its method. And this is the second example of data abstraction. So we have an other class. We have a total attributes, constructor, a method to add number, and a method to get the total. And on the main class, we created an object called A, and we call the add num method, and we enter or put an arguments 10, 20, 30, and we print the total, and we call the get total method. The total is 60, which is correct. So this is an example of data abstraction because we are more focuses on what it does, which add number and get total. We do not know how they implement, how they add number, how they get total. So this is data abstraction. So this is the last example of data abstraction. So here we have an abstract class called car. So this is the general idea of a car with a method called stop, leaving the specific details of how each type of car stops. In this case, we have the Honda class, which provides specific details for how the Honda car stops. So it prints Honda stop and prints mechanism to stop the car using the brake. In the main class, it demonstrates an abstraction by creating a general car object and calling the stop method without needing to know about the implementation details of how to stop the car of the Honda car.
So, good day. My name is Clarissa B. and I'm going to be presenting what is encapsulation. So, what is encapsulation? Encapsulation is an OOP or object-oriented programming technique that is used to bundle data and the methods that operate on that data into a single unit or a single class. So, in encapsulation, the variables of a class are hidden from other classes and can only be accessed through the methods of their current class. Here is the three types of encapsulation. So first is the member variable encapsulation. Second is the class encapsulation. And then there is function encapsulation. So what is member variable encapsulation? In this type of encapsulation, we encapsulate the variables of a class by making them private and providing public getters and setters methods to modify and view the variable's value. Here we have a class named student and there's the private variable string name and integer name. Then there's the public string get name, return name for the getter, and then the public void set name for the setter of the name. Then the public integer get age for the getter for the age, and then the public void set age, that is the setter for the age. If you want to run this code, you would have to have the public class name. So in here, we can see that the student set name is Clarice, and the student set age, which is 20. And then when you print that, you get the name, and then you get the age, and then it prints out name, Clarice, then age 20. Next is the next is class encapsulation. So in this type, an entire class is encapsulated in another class. Only the encapsulated class can access the encapsulated class's members. So here's an example class named eClass. There's a private variable named secret data, and it prints out secret data. And then there's a private string getter called get secret data that returns secret data, which is secret data. So next, there's another class, a public class encapsulating class that calls on the private eClass and calls it encapsulated class new class. And then they tried to print out this data, but it won't work as get secret data is private in the class. So it will print out instead that data is encapsulated. So next is the function encapsulation. In this type, we encapsulate code logic within functions or methods to hide the implementation details from the users. So here's a class called calculator and private integer addition int a in the variables and returns a plus b. And then there's the public method calculates sum int a and int b, and the users will use this method to add numbers using the private method.
So hello again everyone. John Lloyd Alondres is the name, and discussing inheritance is the game. So what is inheritance? Inheritance in OOP is a mechanism that enables a new class to inherit attributes and methods from an existing class. The original class is called the base class, and the new class is referred to as subclass. This promotes code reusability, allowing developers to build upon existing code and create a hierarchy of classes with shared characteristics. Inheritance is a key feature of OOP, enhancing the modularity and maintainability of the code. Inheritance has 5 types, namely single inheritance, multi-level inheritance, hierarchical inheritance, multiple inheritance, and hybrid inheritance.
So let's now proceed with single level inheritance. So ano nga ba ang single level inheritance? So from the word single, meron lang tayong single parent class or superclass. So kailangan isa lang yung superclass natin kung saan mag-inherit yung child class. So let's now proceed with single level inheritance. So ano nga ba ang single level inheritance? From the word single, meron lang tayong single parent class or superclass. So, kailangan isa lang yung superclass natin kung saan mag-inherit yung child class. So, yung sample code natin, yung animal class is the parent class with a method it. Yung dog class naman is the child class or subclass that inherits from the animal class, which is yung superclass, and it adds a method bar. So, when you create an instance of the dog class, it can access both the it method inherited from the animal class and its own method bar. So, kumbaga, meron lang tayong isang parent class or superclass at meron din tayong isang child class na nag-i-inherit doon sa ating superclass. So, let's now proceed with multi-level inheritance. So, ano nga ba ang multi-level inheritance? Basically, it can inherit from another class and then another class can inherit from it. So, kung i-define natin siya ng maayos, magkakaroon tayo ng dalawang superclass. Kasi yung first na superclass, so meron tayong isang superclass, and then yung isang subclass, mag-i-inherit siya dun sa isang superclass. And then magkakaroon tayo ng third class na magiging subclass, and then yung pangalawang subclass na nag-inherit dun sa pinakauna is magiging superclass. So, yung sample natin dito, animal is the superclass of mammal, and yung mammal is the superclass of dog. So, hierarchical inheritance involves multiple classes inheriting from a single superclass. So, in this type of inheritance, meron lang tayong isang superclass kung saan meron tayong multiple class or subclass na pwedeng mag-inherit doon sa ating single superclass. So, sa example natin, meron tayong, ang superclass natin is animal, and it has a method that it. Meron din tayong class or yung subclass natin na una is cat na nag-extend or nag-inherit sa ating superclass which is yung animal. And then, meron pa tayong another class na ang pangalan ay dog and nag-i-inherit siya sa ating animal. So basically, parang yung animal, nagkaroon siya ng dalawa or multiple na subclass.
Next type is the multiple inheritance. It allows a class to inherit properties from multiple parent classes, offering more flexibility in designing class hierarchies. In this example code, it shows the use of interfaces hero and weapon, with methods attack and equip. The warrior and tank classes implement both interfaces, showcasing multiple inheritance. Objects of these classes demonstrate polymorphism, allowing them to be treated interchangeably. The main method showcases the different behaviors of warrior and tank instances when invoking the attack and equip methods. Another example of multiple inheritance is that it demonstrates a composition approach to stimulate multiple inheritance. This code defines separate animal and vehicle classes, each with specific behaviors, namely eat and drive. The animal vehicle class encapsulates instances of both animal and vehicle, allowing it to exhibit behaviors of both. In the main method, an animal vehicle instance is created, and its eat and drive methods are called, showcasing the combined behavior of an animal eating and a vehicle being driven. Next type is the hybrid inheritance. The definition of hybrid or mixture is a combination of two or more things. In Java, hybrid inheritance refers to the combination of two or more types of inheritance. The primary goal of adopting a hybrid inheritance is to modularize code into well-defined classes. It also enables code reusability. In this example, it establishes a class hierarchy with single inheritance. Third is the base class, and both first and second extend it. Fourth extends the first. This method is overridden in each derived class, providing a specific implementation. In the main method, an object of the fourth class is created, and this method is called, resulting in the output fourth. This demonstrates the concept of method overriding in an inheritance hierarchy.
A wonderful day to everyone. My name is Maria Angela May Perez from BSCS 2B. And today, I will discuss the concept of polymorphism in Java. So without further ado, let's know first what polymorphism means. So what is polymorphism? Polymorphism is considered one of the important features of object-oriented programming because it allows us to perform a single action in different ways. So in other words, polymorphism allows us to define one interface and have multiple implementations. So it is derived from the Greek word poly, means many, and morphs means forms. So polymorphism means having many forms. Here we have two types of Java polymorphism. These are the compile time polymorphism and the runtime polymorphism. So let's first talk about the compile time polymorphism, or also known as static polymorphism or method overloading. Method overloading occurs when multiple methods in the same class have the same name but different parameter list. Then these functions are said to be overloaded. Then the Java compiler determines which method to call based on the number and types of parameters during the compilation phase. Next, here is an sample code of compile time polymorphism. So here, the code defines a class named compile time polymorphism. Then the class has three methods named display, and then these methods demonstrate method overloading, so which is a form of compile time polymorphism. The first method takes a single parameter of type int. The second method takes two parameters, both of type int. Then the third method takes a single parameter of type double. In the main method, an instance of compile time polymorphism class is created using new. So the three overloaded display methods are called with different sets of arguments to showcase method overloading. The compiler then determines which version of the display method to invoke based on the provided argument, types, and number during the compile time. So when the program is executed, it will produce output messages, which is in here, showing the values passed to the method. So the output shows that a single parameter method is equals to 10, two parameters method is equals to 20, 30, and the double parameter method shows 3.14. So this code demonstrates the concept of compile time polymorphism using of method overloading in Java. So the next type of Java polymorphism is the runtime polymorphism. It is also known as a dynamic method dispatch. It is a process in which a function called to the overridden method is resolved at runtime. Method overriding achieves this type of polymorphism. So method overriding, on the other hand, occurs when a derived class has a definition for one of the member functions of the base class, and that base function is said to be overridden. Next, we have a sample code of runtime. So animal is the base class with a method makeSound here that prints some generic sound. So dog is a subclass of animal and overrides the makeSound method to print bark. Then here, cat is another subclass of animal and overrides the makeSound method to print meow. So here in the main method, creates object of type animal but refers to them using references of the base class animal. This is an example of polymorphism, where objects of different types, dog and cat, are treated as objects of the common base type animal. So dog is an object of type dog and cat is an object of type cat. However, since they are assigned to references of type animal, only the methods of the animal class are directly accessible through these references. So when calling the makeSound method on these objects, Java uses dynamic method dispatch to invoke the overridden method in the actual objects class. Therefore, the output is bark for dog and meow for cat here. So in summary, this code demonstrates runtime polymorphism in Java, where the behavior of the makeSound method is determined at runtime based on the actual type of the object.